Welcome. When you think about how data moves across a network, you probably imagine the most direct route possible. But what if it isn't? What if your data has to take a long detour through a central office every single time? Today, we're going to look at the ingenious solution to that problem, the network shortcut known as a Phase 2 tunnel.
All right, here's how we're going to break it down. First, we'll look at the problem, this idea of a central bottleneck. Then, we'll explore the solution, a more direct path. After that, we'll get right into the technical details with the packet's three-step journey. We'll touch on a really important quirk about routing, and finally, we'll weigh the pros and cons to get the full picture. Let's get into it.
So, first things first, let's talk about the central bottleneck problem. You gotta understand why our networks don't just automatically take the most direct route from the get-go. There's a reason for the madness. Just think about it for a second. What if your data could take a shortcut? If you've got two branch offices in the same city, why on earth should their data have to travel hundreds of miles back to a central headquarters just to talk to each other? Seems kind of crazy, right? Well, that's the reality in a standard hub-and-spoke setup, what we call a Phase 1 network. Every single packet, no matter its final destination, has to go through that central hub. It's like mailing a letter to your next-door neighbor by first sending it to a processing center in another state. It creates delays, what we call latency, and it puts a massive strain on that central hub. And that, of course, brings us to the solution, a much more direct route. This is where the simple elegance of Phase 2 really starts to shine. And wow, when you see it side by side, the difference is just night and day. On the left, you've got Phase 1, that mandatory detour. But on the right, Phase 2 gives us the direct route. Now, the spokes still need the hub to make an initial introduction, but right after that, they can build their own private connection. It's a total game changer for efficiency.
So the main goal here is pretty simple. Let's enable those dynamic, on-demand tunnels between the spokes. But, and this is the really wild part, the key caveat, this whole thing works without actually changing the network's official roadmap, the routing tables. It's all made possible by three key technologies: GRE, IPsec for keeping things secure, and the real star of our show today, NHRP.
Okay, now for the main event. Let's see how this direct connection actually gets built. We're going to follow a single packet on its journey and watch this process unfold step by step. But before we can do that, we need to properly meet our hero protocol, NHRP, the Next Hop Resolution Protocol. The easiest way to think about NHRP is like the network's directory assistance. It's the protocol that lets one device ask a central server, "Hey, I need to talk to Spoke B. What's their direct public IP address?"
The whole process is beautiful in its simplicity. It's just three stages. First, the initial communication has to take the old, long route. That triggers a request for a direct address. And then, bam, a new dynamic tunnel gets created. Let's look at each one. Okay, step 1. Spoke A wants to send its very first packet over to Spoke B. It looks at its map, its routing table, and that map only shows one way to get there, through the hub. So that first packet does exactly what it's told. It travels to the central hub, which then sends it on its way to Spoke B.
Now here's where the magic happens. As soon as Spoke A sends that packet, it realizes, hey, I'm talking to another spoke. So it gets proactive. It fires off a completely separate message, that NHRP query, to the hub. This is that directory assistance call we were talking about. It's basically asking, can you give me Spoke B's direct number?
And in step 3, the hub delivers. It does a quick lookup in its NHRP database and sends Spoke B's public IP address right back to Spoke A. Armed with this new information, Spoke A now has everything it needs to build a secure, direct tunnel straight to Spoke B, completely cutting the hub out of the conversation.
And there you have it, success. That whole setup process, by the way, happens in milliseconds. It paves the way for a super efficient connection. From this point on, every single packet between A and B takes the shortcut. This frees up the hub's resources and makes communication way, way faster.
Okay, so the data's flowing directly. Everything's great. But there's a really important kind of spooky nuance to all of this. Let's talk about routing, or what you might call the ghost in the machine. Because even though our data is taking a brand new shortcut, the old maps are still in place. And this detail is absolutely critical. The underlying routing protocols, the EIGRPs, the OSPFs of the world, the things that actually build the network's official roadmap, they are completely clueless about this new shortcut. As far as their logic is concerned, the only way to get from A to B is still through the hub.
So what you end up with is this fascinating split. You have a super efficient data path.
That's the actual highway your data is speeding down. But the control path, the network's official map and its decision-making brain, that's completely unchanged. It's a brilliant workaround, an overlay. True deep optimization of the routing itself, well, that's a story for another day. We call that Phase 3.
All right, so let's bring it all home by weighing the good against the not so good. It's really important to take a balanced look at what Phase 2 offers and where its limitations lie.
I mean, on the benefits side, the wins are huge. You're slashing latency, you're taking a massive bandwidth load off your central hub, and it just scales so much better than Phase 1. Plus, it's actually pretty simple to configure. But on the limitation side, you have to remember, the routing isn't truly optimized. The hub is still the next hop according to the routing table, even if the data isn't going there anymore.
And that really brings us to the key takeaway. Phase 2 gives you a massive performance boost. It's incredibly clever in how it creates these direct tunnels on the fly. But it does all of this as an overlay, a trick that leaves the fundamental routing logic of the network completely untouched.
So, I'll leave you with a question to chew on. If these direct tunnels are the shortcut, but the official network map never gets updated to show them, what would the next level look like? What would true, fully integrated optimization be? That's exactly where this story is headed next. Thanks so much for tuning in.